Okay everyone, in this video we're going to discuss multiple regression and nonlinear regression. Now, when we're doing this work, we're going to end up using the data set that we created in our prior merging data set video. This is the video where we combined our weather data from spring and fall and our facial expression data, and we have hourly data with both weather and mood. If you don't remember that, or if you don't have that data file, go back to the past video and watch the merge data SPSS video from our website. So the first thing is, why do we need to use multiple regression? Well, there are times where we're going to be interested in how two or more variables affect another variable. For example, we might want to know how do humidity and temperature affect mood. We're going to examine this using multiple regression. So to start, we'll open up the data set like we have here. Then we're going to go to Analyze, Regression, and we'll use linear regression. Then what we're going to do is from our list over here, we will find the variable that we want to model. In this case, we're going to use positive evidence mean. Just to be clear, with our data set, sometimes we have other variables with a similar name. For example, we have one that ends in SD, that's for standard deviation. You don't want to use that right now. So use positive evidence mean. For independent, what we're interested in is temperature in Fahrenheit and humidity. Okay. Now, actually, let's just start off by looking at just temperature. So we're going to look at the relationship between temperature and mood. Okay. So we'll just go ahead and click on OK. And then we'll see the regression results pop up here. And I won't get into all the details for now, but we can go down to the coefficients and then we can see that temperature has a positive relationship and that it's significant. So apparently when the weather is warmer, people are pretty happy about that. Or at least we were able to pick that up with facial expressions. So that's pretty good news for us. Now let's go through and we'll use regression again. This time we'll flip out temperature and we'll look for humidity. And we'll do the same analysis. Go ahead and click OK. And then we see the same sort of thing here, although actually there's a negative relationship with humidity. Now we're going to come back to this later. But see, we see here that that relationship is significant. All right. Now, like I said, though, we want to look at the effect of multiple variables. So let's look at regression, linear. We're going to have humidity, but we're also going to look at temperature again. And this time we'll have them both included in the same regression. When I click OK on here, we go down to the coefficients. Here, what we see is temperature is still positively related to mood. So people are more happy when it's warmer. Humidity still has this negative relationship, but it becomes less significant. In this case, it becomes insignificant. All right. So what this is telling you is, once you account for temperature, humidity is no longer significant. Now, that said, I would tell you, this is pretty close to significance, and it's possible if we control for other factors, or if we model this a different way. For example, we don't just look at the linear relationship humidity, we look at nonlinear relationships. This could be significant, but we'll come back to that some other time. But basically, this is the idea. If we want to know how weather affects mood, we can look at two components of weather, temperature and humidity, and see how that affects if people are happy or not. Okay? Now, let's say we want to look at some other information. So we may want to look at a relationship between variables where the relationship is not linear. Okay. What I'm going to do now then is look at temperature and humidity to do that. But first there's one, I'm sorry, temperature and time of day. But there's one problem with our time of day. Time 2, if you look up here, is actually a character variable, and to do a linear regression or a nonlinear, we're going to need a numeric variable. So I'm going to do one quick data transformation. So we're going to say compute time. Time is a new variable for us. And this is a kind of a complicated transformation. We're going to create a new number variable. And it's a substring of time2, starting with the first character and going to the second. And this is the kind of number we want to create. So let me go back through that again. We have a new variable called time. It's a number variable. We're converting a string to a number, but we only want to look at the first two characters, so 0 and 6, and we want a number with 2 places and 0 decimal places. When we actually run this, you're going to see if we go to the end of this file, we have something called time now that's a number with decimal places. Okay, now that we have that created, we can go through now and look at the relationship between time of day and temperature. Okay, to do this, I'm going to go up to our data set and we'll click on Analyze, Regression. And there are a number of ways to do this, but we're going to do it actually with curve estimation. Get rid of these. This is from a previous analysis I did. What we're going to look then at is time of day. And we're going to look and write that's the, oh wait, actually we're going to put humidity, or I'm sorry, temperature. That's our dependent variable. And then time of day we're going to put in as our independent. We'll keep these clicked. And then we'd like to look at linear relationships. This is just what we've done before. Then we're also going to look at quadratic. That's where we have a squared term. So we're looking at time squared. And then we're going to look at cubic. This is the to the third power. And in this case, we'll just click on OK. And if we expand our screen, first I'd like to come down and look at the chart that we have. What we see from our chart is we see this just relationship between time of day and temperature, and not surprisingly we see the temperature goes up towards the middle of the day and comes back down. And this is where you can see how a linear relationship, that's what this line is, might be a problem. This looks like a positive relationship over time, but what that would suggest is that when we get into 6, 7, 8 o'clock at night, that the temperature is still going up, and we know that's clearly not the case. So the other thing that we can do is look at a quadratic. That's this relationship that's coming up and down like this. Or we can look at the cubic. So a cubic ends up having more of an S shape. And again, there are other more complicated models in there that we're not going to discuss today. It's outside of our scope. But if you ask me, the cubic looks like it has the best fit with the temperature. And actually, you don't just have to take my word for it. We can come up here to the model summary. We can look at linear, and there's the R squared relationship, and it is significant. So what that says is the linear relationship between time and temperature is significant, but we can see quadratic is a better fit, and it's also significant, and cubic is even a better fit. Now there are analytical ways where we can say which model should we use, but for today's purposes, let's just stick with this. One, let's make sure that there's a better fit. If there is a better fit, then let's look at the shape and see if it kind of makes sense. And then also just theoretically, does it make sense to think that this would be a relationship that isn't just linear? Okay. Oh, and I guess the last thing I'll point out is, the R squared isn't great, but this is because we need to account for other variables. For example, the month of the year, or cloud cover, or some other things like that. Okay, that's it for today.